Well, sometimes you have expectations in your wheat field, but the weather can play a really important factor. And Brian, you have an example right here about that.
Yeah, the Magruder plots give us some great opportunity to kind of look at things. And so I've been watching these plots for the last couple weeks, just observing something that I thought was quite interesting. So I'm standing right in front of the manure plot. So this gets beef feedlot manure every 4 years. If you were to look at the where we put fertilizer nitrogen on, it's really green, really big. And so comparing those plots with the manure plot, knowing the history on this, I would say that we're in year 4, because usually the release on this is we get a good amount in year 1, we get some of the most nitrogen in year 2, year 3 we start drawing down. By year 4 we really see the deficiency. And so looking at the wheat right now, I'd say we're in year 4, when in reality the manure was applied in 2019, worked in, and so we've only had one crop taken off, which was a 45 bushel crop. And so by all rights, this wheat should look very much like the fertilized wheat where we have commercial fertilizer. So that's telling me a story on the nitrogen cycle. When we add something like manure, it's an organic source, meaning it's not all chemically available, and the biology has to work it down into a available source, plant available, the ammonium and the nitrate sources. And that takes time because you have different levels of organics that have to break down. We look at this and there's either one or two things have happened here. We've either had leaching, which we've had a lot of rainfall, or we have not had mineralization, meaning the breakdown of organic to mineral to the plant available. And I think we're looking at a combination of the two, because we have been wet, but we've also been cool. So I really think we kind of slowed down that organic matter mineralization and are not seeing the typical release pattern that we see in March and early April when we really start that organic cycle up and roaring. We have, without question, nitrogen deficient wheat. The other aspect that we're seeing, and we have shallow rooted crop. We don't have a really big, deep rooting structure. A lot of that comes from our rainfall events that we've had all fall and spring. We've consistently maintained kind of a good surface soil moisture, and it makes the plants, I'm a soil scientist, so I'm gonna say it makes the plants lazy. The crop physiologists would get mad at me, but the plants don't really explore the roots. So now we have shallow roots, we have a lack of nitrogen because the rainfall would push the available nitrogen down. We're not mineralizing the organic form, and so we have this deficiency when by all rights we would expect nutrients.
So, going forward, like into, year 2 or year 3, you say it's a delay. Do you expect that maybe it can catch back up, or is that something that you're going to have to continue to manage, and add, more enriched strips or stuff like that?
If this was in a production field and I came in early March seeing this response like this, I would have fertilized to try to bring it back up, try to compensate. The hopes are that we haven't lost it, because we haven't tested to see have we lost it or have we mineralized. The hopes are we mineralize it at some point and it'll be available for year 3 and or year 4. So maybe year 4 is better than our normal year 4s in this cycle.
Brian, a lot of our viewers know that you are actually a professor here at Oklahoma State University with the Plant and Soil Sciences Department, and you actually have a new scholarship program that's going to be taking place here pretty soon.
Yeah, so we're really excited about it. It's a joint venture with the Plant and Soil Sciences Department, Entomology Department, and NEO A&M, the junior college up in Miami. And so we were able to put in, between Dr. Hoback and myself, put in for 2 different NIFA grants, which is a federal funded grant through USDA for the involvement of Native American students in STEM process, a STEM project. And so it's really great. We're looking for 9 students to start this coming fall. Applications are out, and what it'll be is the students go through NEO A&M for 2 years. They're going to do summer internships. They're going to get to work in the brand new greenhouses that NEO has, and then they're going to transition to OSU. In 2 years at OSU, they'll be able to take part in research projects in plant soil sciences and entomology, and they're going to graduate in 4 years with 3 degrees. They'll have Associates of Science from NEO, a Plant and Soil Sciences from OSU, and an entomology degree from OSU. So 3 degrees in 4 years. That's going to set them on a career path for over 25 career path options.
This is like an awesome opportunity, but there is a deadline.
There is a deadline. We have priority deadline for the application on May 1st. We want to be able to share the announcement with the students when they graduate high school. So priority deadline is May 1st. We will extend that if we need to after that point.
Thanks, Brian. Dr. Brian Arnall, Soil Nutrient Specialist here at Oklahoma State University. And if you'd like some more information on the scholarship program Brian mentioned, go to sunup.okstate.edu.